Hi, everybody. Here we go. This is the screen I was looking for. So 13.2, chemical formulas. Just going to take you through this. You guys will catch on here pretty quick, but we're looking at uh, naming chemical formulas and identifying formulas for chemical formulas, for specifically binary ionic. So here we go. First thing, oxidation number. And this is not something totally new to you guys. We talked about it in the section 13.1. It's just now we're applying a name to it. So oxidation numbers is the charge that something gets when when an electron is lost or gained from that atom. Okay, so we talked about before how like sodium has an extra electron, chlorine wants an electron. So sodium gives that electron to chlorine. When it does that, sodium's charge now, it just lost a negative charge, so it becomes positive. Okay? That positive one charge is sodium's oxidation number. Shows charge on the atom after electrons are lost, gained, or shared in chemical bonds. So any compound that we have has to have a neutral charge. So that positive one sodium will combine with that negative one chlorine after that electron is lost and gained, right? So we're going to go through some examples like that. So here it is again. Sodium gives that electron to chlorine. Sodium becomes positive, chlorine becomes negative, and that positive negative attraction, that electromagnetic charge, wants those opposite charges to be next to each other, right? So they form that bond, that ionic bond, because we have two ions. We have a positive ion and a negative ion, a cation and an anion, and they form that relationship because of their opposite charge. Now, so if we think about it, lithium has 3 electrons total, 2 in the first shell and 1 left over. Okay, that 1 left over, it doesn't want that. It wants to be just like helium here with 2. So it loses that electron. Anytime it does that, it becomes a positive 1 charge. Well, so does sodium. Okay, sodium has 11, it wants 10 total. Okay, it has that 1 extra electron, so it gives it away, it becomes positive charge. Okay, same with potassium and rubidium. Okay, they each have 1 extra electron, 1 more electron than what they want. So they are going to give that electron away. And when they do that, they become positive charge. Beryllium, as we can see here, beryllium 4, okay, that has 2 extra electrons. It doesn't want those 2 extra. So instead of gaining 6 more, it just loses those 2. Now it has a positive 2 charge, right? So beryllium, magnesium, calcium, strontium, they all have a positive 2 charge. If we go over to the other side, fluorine, chlorine, bromine, iodine, they all want 1 more electron. They want to be here like these noble gases. Whoops. They all want to be like these noble gases. So they take in 1 more electron. When they do that, they become negative. Oxygen, sulfur, those atoms, they gain 2 electrons, becoming negative 2. Nitrogen gains 3. Carbon is that weird one. Carbon's in the middle. A most common oxidation number might be a +4, but carbon can gain 4 electrons or give 4 electrons away. It's in the middle there. You might see some compounds with either one, but gaining 4 or losing 4 can be the same. Most common is a positive 4 charge, meaning that it loses 4 electrons. Now, predicting ionic and covalent bonds. Remember, ionic and covalent depends on how much elements need that electron. Okay, how much they need those electrons. Strong electron donors are going to be on the left side. Okay, the left side of the periodic table is the side that you see. Those electrons are positively charged because they want to give away those electrons. The electron acceptors, those are going to be like the halogens, the fluorine, chlorine, bromine, iodine, those ones, they really want to gain that electron, so they are going to be electron acceptors. Okay, here's our periodic table showing the strong electron donors and strong electron acceptors. Donors on the left, acceptors on the right. Now, this is kind of an important one to know. We're able to identify whether elements or other compounds are ionic or covalent just by looking at the elements that are in them. Okay, one element in an ionic compound. Remember, ions, positive and negative charge, right? And ionic compounds give and take; they don't share. Okay, in an ionic compound, we will always have a metal and a non-metal. okay, held together by those ionic bonds. Sodium chloride, sodium is the metal, chlorine's the non. Magnesium bromide, magnesium is the metal, bromine is nonmetal, okay? And that's different than a covalent compound, in which all elements in a covalent compound will be nonmetals, okay? All elements in a covalent compound, whenever they're sharing, those are nonmetals, okay? So we can look at a compound and know, okay, I can look at H2O and I see hydrogen nonmetal, oxygen nonmetal, covalent compound, okay? All right, I'm gonna move my picture down here. Oxidation numbers, chemical formulas. So when we look at this here, we know that carbon has that +4 oxidation number. Chlorine has a -1 oxidation number, right? It only wants to accept one. So does that mean that chlorine can't combine with carbon because they don't cancel out? No. Remember, oxidation numbers that on a compound have to equal 0. So we've got one carbon here that it wants to give away 4 electrons. Well, it does that by combining with 4 chlorines. Okay, now I have a +4 and -1, -1, -1, -1, all canceling out, so that net charge on the compound has to be 0. And that's a really important topic. Okay, really important thing to know is that the net charge on a compound has to equal 0. The positive charges will always cancel out the negative charges in a compound, okay? So positive carbon cancels out the negative chlorine in an ionic compound. Now we are going to get into some predicting formulas, okay? So we want to, if I know I've got magnesium and I've got bromine, what the heck is their formula going to be? MgBr, MgBr2, Mg2Br. I got to know what that is, and I use those oxidation numbers to figure that out. Okay, so here are 3 rules for writing binary ionic formulas. Now, I would highly recommend that you have these in your notes. So rule 1, 2, 3, write symbol and oxidation number of the positive element is step number 1. Step 2, write the symbol and oxidation number of the negative element. Okay, so I'll go through an example here in just a second. And then step 3 is make the sum of the charges equal to 0 using subscripts. Okay, so I'm going to show you what all those are again in the next slide. If you need to pause it right now to write down those 3 rules, do it right now. Okay, so next thing here, writing the formulas for these. So we can write down these formulas. I think I have a slide here. Oh no, I don't have a slide showing you how to do this. And I'm not able to write on here. So what I'm going to do is just kind of talk you through it. There's an example in your book as well. So you'd be able to take a look at that, and you'll have some section review questions that will go along with this also. Okay, so potassium has a +1 charge. Bromine has a -1 charge. Okay, those 2 charges already cancel out, right? +1, -1, I need those to equal 0. They cancel each other out. So my formula will just be potassium bromide, KBr. Okay, beryllium and fluorine. Beryllium has a +2 charge. Fluorine has a -1 charge. Okay, so how many fluorines will I need to cancel out that 2 beryllium? I need 2 of them, right? So now my formula becomes BeF2 because I need 2 fluorines, 2 negatives to cancel out the positive beryllium. Again, BeF2. Iron 3 and oxygen is a little bit different. Iron 3, so +3 charge, oxygen -2. So that one is a little bit trickier to match them out, to cancel them out. I got to find that least common denominator, or no, least common multiple, sorry, least common multiple, which would be 6. I multiply iron 3, I multiply that by 2. So I'll have Fe2O3. 2 irons makes a charge of 6, and 3 oxygens makes a charge of -6, canceling them out, bringing that charge to 0. So again, Fe2O3 would be my formula for that one. And lastly here, or not lastly, we got another slide after this. Sorry, guys. So there are some compounds that we call polyatomic, or some ions that we call polyatomic ions. They're a group of atoms that are an ion. So they're things that are bonded together chemically, but they do not form a compound because their charge is not 0. Okay, they do not have a neutral charge. For example, carbonate, like calcium carbonate. Carbonate is part of that. Carbonate has that -2 charge. Okay, so calcium carbonate might be found in antacids and things like that. And in this case, that CO3 is bonded together, but it is an ion because it has a -2 charge. So polyatomic ion CO3 with a -2. Polyatomic ion is an ion that contains more than one atom. So it's an ion because it has a charge. Polyatomic, many atomed ion. Polyatomic ion. Okay, ion has the charge. And now we're not going to do anything with polyatomic ions apart from know what they are. We are going to focus on binary, right? So binary means we have two atoms combining together, and specifically binary ionic. So we have two atoms combining together, two elements combining together to make this ionic compound. We already learned how to do the chemical formula, and now we're going to look at how to name them, okay? So the first thing we're going to do, so here's your 3 steps. Again, I highly recommend you writing them down, writing the name. So first step is to write the name of the first element, okay? If it's like sodium would be my first element. It's a positive element. That's the one that comes first. So sodium. Then I write the root name of the second element. If my second element is chlorine, my root of chlorine would be chlor. That's the first part, kind of the main part of my atom name. So far I have the name of my first element is sodium. The root of my second is chlor, so sodium chlor, and I add the suffix IDE. So sodium chloride becomes the name. And here we go. This is just another example of that using a different one. So here's my formula, MgBr2. Write the name of the first element, magnesium. Write the root name of the second element, bromine, brome. Okay, and I add that suffix IDE. The name is magnesium bromide. Okay, so I would also recommend writing down that example. I am going to have some questions of these in your section review questions, and they're not going to be easy if you have not watched the video or if you did not look in your book. Okay, thank you guys. Section review questions next. See ya.